the virtualization visionary piece was once you take all of those modules and you consolidate everything and it's all virtualized and you have it inside of VMware clusters, you have the opportunity for scheduling certain jobs and using the capacity a little more wisely than you would have otherwise. And I'll get to it a little more on the next page and the page after that, but they had about 40 racks of really expensive Sun servers in their data center. And they didn't have anything virtualized, so the ability to move workloads around and schedule jobs and park certain modules to bring other modules up and allow those modules to run to do their indexing or different types of queries for BI, et cetera, wasn't really available at that point in time. So they had a really big, expensive, hot, leaky, old school, high available, nevertheless, installation. And so what they wanted to do was go from the OLTP or the transaction processing during the day to switching to the OLAP at night so they can actually park the OLTP applications during the evening and spin up all the OLAP applications so they could actually run against the database and bring all the clusters that they're using now up to full utilization. And at some point in time, it'll be more of a parking lot approach where you have your training, your sandbox, all the things, and you can keep those on a temporal basis going around the clock so you're always getting maximum utilization out of your cluster. So that was kind of the vision in the forefront that drove everyone to want to do it virtualized. Any questions?
Do you have any benchmark on OLTP rate that you want to achieve on the virtualization versus hardware or the same?
The maximum transactions per second?
Yeah, what any benchmarking or what have you achieved versus what the virtualization requires? Any good benchmark?
The actual database itself wasn't virtualized, so the big 2.5 terabyte database is still running natively on Red Hat. And the reason for that was you can't get enough virtual CPUs on a single NUMA node to actually achieve the level of performance that you can when it's non-virtualized. So in the future processors that we're making right now, you can get an 8-core that's in a single NUMA node with 4 channels of memory, and you can do 8 virtual CPUs with VMware. And then as time goes by and our roadmap progresses, we'll have 10 cores. It's actually sampling now. It'll be probably shipping next year. VMware should be able to update their software to allow a 10-core single NUMA node. And we're projecting right about at that point in time, they'll be able to virtualize that database. So for now, there were a couple of the databases and a few of the modules that were left native. The maximum is 8 virtual CPUs. And you would need what's called an Halo EX. So for HP, it would be like a DL580G7. And you can put, I think it's 250 gigabytes, 256 gigabytes with 8 gig DIMMs and 8 cores on a single NUMA node. And if anybody doesn't understand what I'm talking about NUMA node, when you're designing a server, you have a server with cores here and a memory controller sitting off the top. You have another processor here, and it has to cross what's called a QPI link or a quick path interconnect. If you have a virtual machine that has to use CPUs from both of those or make a remote call to memory, you get about a 15 to 20% performance degradation. And we're working on how you solve that, but it's going to be a little bit longer. And so what's happening, though, is the natural progression as the amount of cores grow and the amount of virtual CPUs you could use inside of a single VM, the bigger the applications you'll be able to address using virtualization. Any questions on that one? That was a good question. Thank you. Let's see here. So for the original architecture, they had a pretty large Sun installation. 80% of the environment was the 440s through 490s, and there were a couple of 880s and 890s. About 90% of that was 4-socket. Only a few of the 8-socket boxes existed. Solaris 9 and 10, they were using Veritas Foundation with Veritas Cluster for high availability. I would expand on your question. The other things that didn't get virtualized in the migration were the high availability clusters at this point in time, because that is actually still limited to one virtual CPU when you do that. So all the stuff that has to be available 24 hours a day was kept natively. But as time goes on and VMware and Intel, and we progress our roadmap and the technology, we're actually working on that issue right now. What's that? Yeah, fault tolerant. So clustering, right? Veritas clustering, where one box goes down, you have the twin box, data's duplicated, everything goes both ways, and you can fail it over immediately. Yes? Yeah, it was Red Hat 4.6.
Was that a higher risk strategy, or what was the rationale for doing that as opposed to keeping it on Oracle x86, or excuse me, Solaris x86?
The corporate standard at this company was actually Red Hat already, so they had a pretty good team of Red Hat engineers and architects that had been using it for quite some time, and they weren't as familiar with Solaris on x86. So mostly I would say it was process-driven, and it was driven by the expertise that was already in-house. Oops, sorry.
Just out of curiosity, given the Oracle purchase of Solaris and making that proprietary Unix, how does that impact using Oracle, Solaris in future x86 systems?
From an Intel perspective, I can answer your question is we like them all. It can be Solaris, it can be Red Hat, it could be however you want to do it. We have a team of about 3,000 guys that's a couple hundred of those spend a lot of time with the guys in the Solaris team and the Red Hat team doing optimizations. And then we also do kernel optimizations for all Linux. Does that answer your question? There's still a lot of HP UX installations out there on Itanium. There's still a lot of I actually know people that still have alphas running and some other stuff in their shop. I don't know if I can speculate on what you're saying, but I think that I know enough people that have to make that decision that when they're looking for support, if they have very specific application needs, there are a lot of telcos that will go with Unix for some very specific reasons. There are a lot of enterprise IT shops that like to stay with Linux because it's a little more tailored to that side of the business. And that's kind of the trends that I've seen personally. Any other questions? That's a good question. Thank you. All right. So switching from the old to the new architecture. They went from a lot of Sun, Solaris, Oracle 10G, DMX, EMC to x86-based hardware. Most of that was Nehalem-based or X556070 microprocessors. Those are the 4-core, 3-memory channel, dual-socket boxes, DL380G6s. The 580G5 was the processor that we called Dunnington. It was an X7660 or something like that. That was a 6-core, 4-socket with the memory controller down on the actual chipset. So it wasn't NUMA. There was no necessity for NUMA where you had one memory controller that controlled all the memory space. 95% of the switch of the physical servers went to DL380s. The 580s are actually used still for the single instance or the large instance databases and for a couple of the applications that need that type of horsepower. And those are the ones that we were talking about earlier with the NUMA node question. So it's Red Hat, Enterprise Linux 5, Veritas Cluster Suite for the application pieces that still need to be very high availability. And then it was VMware vSphere, IBM DB295, and then the EMC VMAX. And I'll go into the VMAX and the LUN limits and all the things that they used to do the sizing when they were doing it in the next few slides. So let's see, some of the design considerations. Existing utilization, we used, my brain is not here. VMware Capacity Planner, sorry. was the tool that we used to actually do some of the existing utilization and sizing. And we used some of that data and the power data that we had to translate that into SAPS benchmarks. I'll get into that on the next slide. The high availability considerations, because of what we talked about with the one vCPU, is the only one that you can do fault tolerant with today. But as that progresses, you'll be able to use multiple vCPUs, hopefully someday soon, to do fault tolerance inside of a virtualized cluster. The number of LUNs. So the number of LUNs that they had is really large, and it's because DB2 can stripe across all of the LUNs and actually gain the performance from doing that. So they had the size based on the cluster size, and there were 256 LUN limit inside of a cluster. So I think there ended up being 3 or 4 clusters, and they took some applications out of their sandbox, out of their production, out of other environments, and put them into the different clusters and sized the clusters that way. So it was a lot of serious storage concerns in how they did all of that. The other thing that they did is they kept it on RDMs instead of going with VMFS or VMDK files, just because they were using the software that does all the snapshot and replication, which was already set up and running, and they had a storage team and a database team that was really familiar with that. And the performance gain, there is a little performance gain there for VMFS and VMDK, but it was kind of negligible compared to the cost it would have been to retrain everybody to use an entirely new storage subset. And then when you're making such a dramatic change already, that would have just added more and more and more complexity to the migration that was already done, which you can see was, in my opinion, fairly dramatic. The amount of data that they had, that was the Unicode discussion that we had a little bit earlier. When you go from non-Unicode to Unicode, the size of the data expands because of the amount of metadata and all the other things that happen when you make that change. And then business continuity. The only thing that didn't change from an underlying perspective in their architecture was the interface that the users use. So no user was ever affected by the change, and the interface that they have is still the same, except they've seen performance gains around 60 to 70% in some of the batch job times that they're doing, and I'll go into that in a few slides. Any other questions or opens? All right. So this is where I made the bet with one of the Intel executives for a massive amount of change when I said that, they're going to switch their database, their operating system, their underlying hardware architecture, and do all of these things and then virtualize it at the same time. They just kind of laughed at me. So this particular executive was at a bank in somewhere in South America the day before, and they were talking about going from Alpha to Itanium, and they were talking about high availability and mission-critical applications, and they wouldn't even have the discussion about using just x86 architecture for their mission-critical. And so I said, well, hey, when I get this white paper out and do this presentation, you guys all owe me a promotion. I didn't get that, by the way. But I did win the bet. So if you think about the amount of variables you had, going from the old architecture to the new architecture and doing the sizing for that was a pretty interesting spreadsheet that we developed. And you're seeing the results of that up on the top right. So you can see the number of virtualized servers. Actually, where's that little pen? Laser pen at? All right, you can see for a DL380G6, and sorry if this is an eye chart, it was right around 26 virtualized servers and 26 total servers. We actually had to back off of that because of the database wouldn't run with just a 4-core NUMA node. It needed a little more horsepower. We sized it at about 16 580G5s, which was the older 4-socket architecture that Intel had. This was all done probably about a year and a half ago before we shipped the HP shipped the DL 580G7s. So there would have been about 16 of those virtualized and about 22 total. And this was just for all of the instances in North America and the data center they had there. This actually went global, so there are a little more servers than this. But the interesting thing that we did is does anybody use VMware Capacity Planner? Install that agent on top of any of the servers in your data center so you could read, what's going on, how much utilization you got, application performance. Interestingly enough, when you do that with SAP, you can take that amount of utilization and you can go to SAP's website where they publish all of their SD results by vendor's box, and you can then deduce, okay, if I'm using this much CPU utilization on average, and I know my benchmark at a 90% is this many SAPs, well, if I reduce that using a quick algorithm in Excel, I can tell you, based at 10% utilization, I'm using this many SAPs, whereas at 90% I was using this many SAPs. So pretty easy one to do. And we did that for about 117 or 180, I think it was, servers, and looked at the total overall SAPs that they were using, which was projected, I don't know, I think it was 20, 25, 30, somewhere around there, or 20 or 22. Sorry, it's been a year since I looked at that spreadsheet. But if you guys understand what we're saying, so now we can tell you how many SAPs they're using, both in Capacity Planner is nice, gives you the data in average over a long amount of time, and they can give you the peak amount of data. So we looked at the average and the peak, and then we translated that using the same SAP SD benchmarks to virtualized IA. So I have a team in Arizona that was doing all the benchmarks back then for the DL380 G6s. That was telling me how many SAPs per core I could get. And for a Halem or a DL380 G6, that was about 2,678 is what we projected SAPs per core. So we knew, if we have 100 Sun servers producing 20,000 SAPs, it would take 10 or so, maybe 9 Intel-based servers to do that same thing virtualized, because we could stack all those applications using VMware and drive up that utilization. Any questions on that one? So it was a pretty simple translation. I did that with the help of a couple guys down in Houston. You can guess which company that was. They have a really good at spreadsheets, by the way. And then at the same time, the other things that we had to think about were the amount of memory and the amount of IOs. Actually, the amount of IOs were so minimal, and the amount of IO that you can push in and out of a DL380 G6 is so much more these days that it was negligible. And the memory size and capacity was a concern for a little bit, but I think it's actually settled out with the advent of 4 and 8 gig DIMMs. So the amount of capacity you can fit into the new boxes is much greater. So any questions about how we did the initial sizing? I'm sorry? Can you do me a favor and hop up to the microphone right there? Ooh, that's what I needed one SAP expert for. But if you hit me up after the class, I can get somebody that knows how to do that in this room. Yes?
Could you talk a little bit about memory concerns? Can you throw 128 gigs in a couple of boxes and have it go down to the VMware cluster? Was there a concern about being able to evacuate those in a manner?
I'd say there's always a concern when you do that, but if you look at how they had their storage infrastructure and the RDM set up, all the data was pretty much safe except for the few transactions that might have been there. I think that most of the actual applications were running on a single vCPU as well. I don't have the answer to that question directly, but some of the other companies that I've done similar things to this for, if you have your virtual machine and all the transactions are being synced to a cache that's sitting on a disk array, and then you have all of your your LUNs sitting on other disk arrays or the same disk array, everything is fairly protected, and you might lose 1 or 2 of the transactions. So even when you have a node failure, you can still do an instant migration to another node and bring it back up, although it's a cold boot. So there is a little bit of downtime. And depending on how you design the redundancy of your SAP modules, you can pretty much avoid all of that. All right, so here was the slide that won me the bet. When I did the original sizing with the team down in Houston from another company, we expected a reduction of around 70%, and we were trying to be conservative in our numbers when we were doing the SAPs translation, along with the memory and the IOs and all that stuff in the spreadsheet that I was just talking about. The actual results were a physical footprint reduction of 90%. They went from 40 racks to 4.5 racks. You used to be able to walk into their data center and see, just rows and rows and rows of servers. Their storage footprint went from 4 to 1 based on the compression that they were receiving from DB2 and the new compression technology that they're using. They went from 180 plus kilowatts to about 29 kilowatts of power usage. And one thing I haven't pointed out, this company was very limited in data center space. So being able to go from 40 racks to 4.5 was very beneficial for them because they were almost in the midst of having to build a new data center with a new power plant and all the other things that you need to go power and cool that, which is a huge capital expense. From about 1 million or 1.8 million BTUs to about 200,000 BTs of cooling. They planned actually, so we actually planned for 65% virtualization and achieved about 81%. So about 19% of the applications in the databases aren't virtualized yet today. And those were from some of the limitations I was telling you about earlier. And then they saved a ton of money in hardware and OS maintenance, which is always kind of a bonus. Any questions on the results? I've heard actually from some of the users that they were seeing a 60 to 70% improvements in performance from applications. Yes?
Over what time did it require to achieve these results?
6 months. The whole project took about, I would say, just over a year from the time that I was involved. But the actual migration was done, I believe, over about a 6-month period.
Have they previously done the Oracle DB2 resident data? Or was that, were you not doing that?
My understanding of the Oracle DB2 was that there was a team at IBM that helped with some of the actual porting of the data over, and that one of the variables that nobody could figure out was how long the actual port was going to take. So when that all happened, it was over a weekend, and it was kind of a tense moment where, are we going to be done? Because that amount of downtime is pretty valuable to a corporation that large. Any other questions? All right. So here you go. Overall, 11% performance found during the POC. Some of the batch jobs went from 40 plus hours to less than 12 on a live system. Some of the other benefits were improved database patch management and a little simpler way to manage everything. DB2 is pretty well integrated with SAP from my understanding. So there's a lot less patches that have to go out than did with the previous database that they were using. And it was about a 62% compression, which when you're talking about terabytes of storage that's mirrored and striped across multiple disk arrays can be a large amount of money that you can save. So just to review, when I started with this one, there were multiple vendors involved. There were a lot of people that were expertise in one area, but nobody on the team was the general expert for all of the different things that happened during this migration. So this company, in my opinion, is fairly siloed, kind of like my company. So no issue there. But they banded together a team and put them in a room and said, you guys are responsible for this. Here's your timeline. Go get it done. And these guys really got it, in my opinion. And they chose the right time to do it, which was kind of in a down period over the winter time, which made sense for them, I believe. They obtained their senior management approval and made the business case. Some of the data that you're seeing on the previous slide for that amount of compression and the amount of saving and performance improvement was presented early on from some of the projections that we were able to do up front, translating SAPs from a RISC environment to a virtualized IA environment. And if Intel's one of your vendors, you should engage us early, along with all the other vendors that were involved in this particular migration. And, of all the big virtualized instances that I've seen get migrated and all of the latency tests that I've done with my engineering team, I think these guys really got it the most from a risk it all and go big perspective. Yes?
How much of the risk was on the hardware side versus the software side? You're converting all the software elements in that environment. Who's doing the regression testing? And I mean, 6 months is incredible. I mean, it takes something to this scale, with this new software elements, and we go for 6 months.
Yeah, so they had a whole team that was working pretty much double time doing that, and they had a lot of involvement from the guys over at IBM with DB2, helping them doing some of that testing. Most of the applications they had already had running in native Linux, so a lot of the modules that you were talking about were already operating in Linux boxes and random sites all over the world, so not all of it was Sun in the very beginning, but it wasn't necessarily virtualized. So they did have a line of sight into those applications. If you look at the philosophy that I think they used, it was they went pretty big risk on the operating system, the database, and really the underlying connections for that. The sizing of the hardware was pretty straightforward when we did the translations. They went fairly low risk on the storage side and kept everything with RDMs using EMC's management tools, which they already have, processes in place for replication, both offsite and then snapshotting. So that piece of it was a little low risk, or they kept low risk on purpose. On the networking side, everything was sized, and when your networking really wasn't an issue for this type of transaction processing. Whereas I've had companies like FedEx that I presented with last year where networks became a huge bottleneck for large transaction processing. So I would say most of it was in the operating system and the software side. And then the virtualization piece has been proven out time and time again for these types of things. And they had a lot of those modules in place.
So the software really was more in the database porting as
It was the database got ported and still runs natively, and then the applications were ported and run virtually, 81% of them. And they're actually actively looking at how do we get that database virtualized so we can add some more redundancy inside of the environment. That was a question, right?
What do you attribute to the 11% performance?
I'm going to say Intel processors, but I'm kind of biased on that. There were a number of things. I would say part of that is the switch to an EMC VMAX array when you're starting to use solid state and much more memory to cache in front of the fiber channel drives that they were using. Most of the applications that we're talking about with SAP and with DB2 are disk limited, most of the database side of it. So I would attribute most of it probably to the storage improvements between the DMX and the VMAX. I think that they were so underutilized with their old environment that if I were to say it was an Intel processor making it better, nobody would believe me, including me. So I would give it mostly to the storage side and the switch and keeping it with RDMs, but going to a better storage array.
19% of the application
Big database and high availability. So all the stuff that needed to be clustered for instant failover and needed to run on multiple socket boxes, you can't do that in a virtualized environment yet. So all that stuff stayed with Veritas cluster using Red Hat. And then the big databases that were too big to fit on a single 8-core NUMA node or 10-core NUMA node were kept on native 4-socket with 24 cores. So those are the characteristics of most of those. It was the hardware sizing and what you can and can't do with virtualization quite yet. Working on that, though. Yes?
Did you guys try and fail the Veritas clusters, or was it a support thing?
Did we try to fail over the Veritas clusters?
Did you try it in feature and fail, or was it just unsupported by Veritas?
It's unsupported for more than one virtual CPU. So for some of the applications where you need multiple virtual CPUs because of the horsepower needed just to run the application, you need to keep it native for clustering. Yes?
Did you create a roadmap of next steps so that there'd be a version 2, version 3 as far as enhancements for the application going forward?
I didn't create the roadmap, but from what I do know of the guys that did create the roadmap, it was kind of the slide that we talked about earlier where they're talking about the parking lot and the desired future for what they call basis. And that was the ability to take certain jobs that don't need to run during the day, such as the OLAP jobs, and allow the OLTP jobs to run during that point in time to drive up the utilization of the cluster or the clusters, because there were multiple clusters, And then during the nighttime, start to use the OLAP jobs or the jobs that are running queries and doing indexing and on-the-fly compression of the database, stuff like that. And then as you get to the point where you can, add the high availability into the virtualized environment and get the bigger databases virtualized as well, you can also add high availability to those things. Then you don't need the extra set of hardware sitting around to do that with. So you're lowering your capital expense there. That was the...
You just see that from your perspective on the processor side, with the advent of the G7 now, that would seem like a major opportunity to take those systems that were all on the 7400 right now and move over to AMX.
Oh, it is. We just, with the timing and everything, the G7s were just becoming available, and then there was a little slip in the shipping schedule, so it made sense just to keep it non-virtualized for now and take the low-risk path on that side. But they're actually actively testing that right now. So we'll go there. Good question. Any other opens or questions?